Our speaker today from Doulos is Dr. Christoph, who's a Doulos certified training instructor based here in Munich. Christoph? Yeah. Okay. So I'm going to hand over to Christoph now.
My name is Christoph Söhnel. I'm working as an independent UVM coach and a Doulos certified training instructor and representing today Doulos here. I want to present, say, what happened, say, during the last years with Doulos EasierUVM. EasierUVM was introduced, say, in 2000. EasierUVM was introduced in 2011 at DVCon. It was a very simple approach with a few coding idioms and some templates, what we have provided. And this presentation is intended to show the progress we made so far. It's still not really complete, but we expect this to become complete in the next few months. This is the agenda. We have 4 topics. First, I want to dig in a little bit to the motivation coming to an introduction to the EasierUVM. And this is what we are currently adding to the EasierUVM. That means we have quite a lot of coding guidelines which will help the users to write consistent code. And the second thing, this is now a real jump to improve productivity, because we are adding a UVM Framework Generator which helps to set up a complete UVM verification environment at the beginning and saving a lot of time. Okay, back. Our story starts with System Verilog. System Verilog became the language of our choice for functional verification. And because it doesn't tie us to a proprietary language and not to a corresponding tool and not to a corresponding vendor. And we love it because it's actively supported by all the main tool providers which provide us with simulation software. On the other hand, System Verilog is a very comprehensive and complex language, and it needs a lot of effort to learn the language and to apply, but also for the EDA companies to implement all the language constructs. Okay, UVM, Universal Verification Methodology, is the System Verilog class library which supports the functional verification. UVM is actively supported by all the major vendors, and this is a good thing for the users. Because there's an interesting relationship. All the EDA companies have to support the UVM because they want to be competitive with one another. And this is a good thing, say, for the users, and because this encourages the users to adopt UVM. And this, again, gives, say, the vendors more money to make the right investments. Finally, it helps us to drive, say, good and consistent System Verilog implementations and increases, say, the confidence for System Verilog adoption. We have seen, say, in Doulos, in all phases where new functional verification approaches came in, a certain increase in training. It starts with AVM from Mentor, and we saw this with VMM, the UVM, but the biggest increase was with the UVM. Okay, the UVM itself is really complex and it's challenging, and finally, because the UVM is so big, it takes a full day training course to teach, say, the UVM functionality and the UVM library constructs. But this requires additional 4-day training course covering the system Verilog for verification only. And this again assumes that we have a certain knowledge in Verilog. Okay, but when you come out of the UVM training course, you might not be able to start immediately with a good project in an effective way. The next thing is really to think about what could help. We see, that some tool providers are offering graphical environments to put UVM environments together. We see, consultants offering coaching services, and we see the appearance of coding guidelines and implementation guidelines for UVM. Okay, I said UVM is itself challenging. We have the UVM class library around 300 different classes, which can be used for constructing a verification environment, for implementing sequences, tests, and things, what is necessary for verifying designs in a good way. What we are missing, currently, is really comprehensive documentation. We have, the reference guide, we have the UVM user guide, but finally it does not answer all the important questions. There are quite big gaps for applying the things, and a lot of people say we need for UVM a certain methodology that we can really use the UVM in a good way. And this is one thing we are addressing here with our EasierUVM. Okay, this is a slide which comes directly from the EasierUVM introduction in 2011. It was aimed at mainstream VHDL and Verilog users, that means not VHDL experts. And finally, it was, the goal was to give them the good advice how to use the constructs in the UVM by advising to use, certain simple concepts and coding idioms. The EasierUVM does not mean it's a completely new UVM. Finally, it's UVM. It's a subset of UVM, and it gives you, a starting point, and it allows you to expand all the constructs you need, in future times, step by step. But learning UVM is still not easy. It's a lot of effort behind. Okay, this was with respect to this. Now, with the second version, we have still, the same principles, but what we are adding now are specific coding guidelines. This is not to say you have to do this exactly this way. It is one way you can do the things. And finally, we have, this automatic code generator, which helps you to improve and to increase your the productivity of generating the verification environment. Okay, what are the benefits? First is really what the intention is. We want to help, say, companies and verification engineers to learn the UVM, to get, say, quite a fast ramp up with the knowledge. And what is important to avoid, say, all these pitfalls and all these, say, simple errors you are doing during implementation when you are coming maybe from a different language. If you, for instance, or what I have seen in all my UVM projects is, say, in the first 4 weeks, say, 25% of all errors are related to the case sensitivity of system Verilog and to the semicolon in the wrong place. It's very basic, and if you are following, say, the guidelines from we are providing, then you might be able to avoid a lot of these things. The second thing is with the code generator that we can save a lot of implementation time, but also avoid a lot of these, say, simple errors. Because this code generator helps you or implements a complete and running environment. It executes, say, sequences, but it doesn't stimulate the design because it doesn't have any bus function model inside. And the interesting thing is, this might be of interest, say, for the project managers, say the average is that we can, depending on the size of the design and the number of functional interfaces, we save about 6 weeks of implementation. The other thing is that you are implementing your environment in a consistent way. Just we have seen in the presentation before that we had problems, say, with the integration of different UVM environments. If you are following the guidelines and using the code generator, your environment is exactly the same, and this might avoid problems like this, and it reduces also, say, the burden of supporting UVM code and maintaining the code. Okay, this code generator is written in Perl and will be released in the near future with an open source license. That means you can take the code. It's because it's not compiled, it's not encrypted, and you can modify the code to your needs, to your requirements. So, yeah. Okay, with respect to the coding guidelines, this is a list of the sections we have in our coding guideline document. If you are looking to the details, there's nothing which is really revolutionary. It's only we are addressing a lot of things which are very important for verification, and we give here, say, a lot of quite good descriptions how to implement UVM environments, how to perform the coding. Yeah, it's mostly common sense, but it has more insight than the simple UVM does. Okay, the coding guidelines are containing also certain coding patterns for all the most important constructs we are using. Okay, this is for the UVM components used for structuring an UVM environment. We have here, say, the sequence items which are generated from a sequencer, and this is the sequence. These coding patterns, we are describing what is the order you have to implement these things and which methods has to be overridden. Finally, this results also, say, in a quite generic but repeatable UVM environment that we know how to structure for things. And finally, this helps us, say, to think back to a training course to get the ideas back and what we have learned there. Okay. In addition, we are providing certain examples, code examples, not only for templates, why we see here, say, what is important. This is now for the UVM component with analysis ports, virtual interface. That means this is so-called transactor, and we see here which methods have to be implemented. Finally, this complements the code generator. It relates all the things together. The last point is, say, for code generation. The output from the code generator provides us, firstly, say, a certain database. That means we are storing the data, say, depending on functional interfaces. It's all packaged into system Verilog packages, and this is a list of files which is automatically generated and provided to you by the code generator. And if you look to the things, we have here, say, the agent, we have the coverage, we have driver, we have monitor, sequence item, sequence lib, sequence of all what is content of an UVM environment. Finally, it's some boilerplate code. What we have also is, say, some placeholders and, of course, examples. Looking to the boilerplate code is here. This is now, say, for sequence item. We have here our data members and all the functions we do need for implementation, for constructor, and it continues, but it should give you only, say, a certain impression. Then we have, say, placeholders indicating where you should add, say, your user-dependent or application-specific code, as shown here. And finally, we have, say, certain code examples inside that you will override for your individual application. This is now, say, our top-level module with passing here the virtual interfaces to the configuration DB, and here starting, say, the clock generator. Okay, and we are proud to provide you with training services and consulting, and you're invited, if you're interested, to the Doulos desk, especially to have a look to a first prototype of the code generator. Thank you.
So, Christoph, we have one question online, which is an obvious question, I guess. How much of this is freely available? How many of the templates and boilerplates and generation is freely available to people?
Okay, it's still not ready, say, but it will be available at the beginning of next year.
And for free or at a cost?
No, it's. I said it is the code generator will be open license, open source license. That means it's free to everybody.
Okay, thank you very much. I found that talk very interesting because I think, again, coming from Mark's talk, the whole industry is adopting UVM. I think, Mark, you said 87% of companies now use UVM, but we do find it very, very hard for people to use. People find it extremely difficult to use, and we find with our customers as well that one project uses it differently to the second project, so the actual reuse between projects is not as high as it potentially could be. And Mark's nodding, so I'm hoping that's for a mentor as well. So yes, so this making it easier for our industry, I think will make it a lot easier to adopt in a much more reusable way. Are there any questions from the audience? Let's sit here at the front next to Joe.
Hi there. So You said you're making these recommendations to help people, I guess, get past some barriers with UVM adoption. Do you think that the members of the UVM committee would tend to agree with the recommendations you're making, or do you think that they differ in some ways? Because I guess if people are giving different recommendations, this is actually what's happening, I think. Even this will just be one more set. So how okay, can you talk about that a little bit?
Okay. The intention is to give these recommendations, say, to the beginners in UVM, and it's considered as a certain input, and because it's only what we are recommending, and finally you can take parts, or you can consider this completely. You can take parts, you can make modification. It's up to you what you are using. And I believe there might be some conflicts with company-specific guidelines when you have to modify.
Okay, because I know in the committee, because I was on the committee for about 4 years, there was a big effort not to agree on these things because different companies had different views on the basics. But it sounds like this is then just adding one more, but you don't see any consolidation of these recommendations.
To be honest, I'm working see so many sets of good coding guidelines, and I did not see so many instructions how to structure the code and things like this. And there was always discussion making projects longer and maybe made also say hours.
Okay, thank you.
Thanks, JJ. Thanks, Christoph. I guess what happens there was maybe our industry standardizes and then the market innovates around the standardization. Maybe the market will pick which ones they like best in terms of those innovations. So
I think making a standard, this is standard, would not work.
Yeah.
This is the reason, because we are not, say, a standardization organization. We are giving, say, recommendations from our side as a training company, and in my view, it belongs a little bit to our tasks to provide things like this.
Okay, we're going to go into the break now, so thank you very much again to Christoph. Thank you.